All right, here we go. What are rational numbers? Rational numbers. Okay, period 1 didn't get it till the very, very end. I was about ready to give up on them. What are rational numbers? What?
7.
7. 7 is a rational number, but what are they?
Oh.
Whole numbers. Yes, whole numbers are rational, but the definition of rational will be... Ooh, I think somebody just said it. Yes. It's basically your fractions. Okay, so what are fractions? Okay, like 2/3 is a fraction, like -1/5 is a fraction. How about the number 10? Is the number 10 a fraction?
Yeah.
Because it's really 10 over 1. Yes. So when you said whole numbers, somebody said whole numbers. Yes, whole numbers are fractions, 10 over 1. But these are your typical fractions. Okay, now there's something missing in the next box. It should have said algebraic rational expressions. Rational just means fractions. Algebraic will mean it's a fraction with what in it? Yeah, but what do you think of when you think of algebra?
Plus or minus.
Not pluses or minus, do you?
X's.
X's, yeah. You guys, algebraic rational expressions have to have X's in it. So, hey, x over 3 is an algebraic rational expression. X minus 7 divided by, 4x. That's a rational expression, okay? All right. What are you going to do today? Well, the big word today is what? Simplified rational expression. So simplified just means take your fraction and do what to it?
Break it.
What?
Break it.
Break it down. There's another word for break it down. Simplify. Another word for simplify. Starts with an R.
Reduce.
Yes. Reduce your fractions. That's all it is. Okay. So guys, here's what you're going to do right now. You're going to reduce. All right? Now I want you to notice something. On the top of the fraction, you have what? A monomial. On the bottom, you have what? A monomial. The second you see monomial over monomial, you are allowed to reduce it. Okay? Now, 8x over 12x. I get that most of you can probably do this really quick, but I'm going to show you something really off to the side. You don't have to do this. But can I ask you this? What is x divided by x? Oh, I started wrong. Hang on. What is a 4 divided by a 4?
1.
Okay, because why? Because the numbers on top and bottom are exactly the same. Okay, so does it work with x's?
Yes.
X divided by x?
X.
Is x divided by x 1?
What's it have?
Why?
Because of X equals 1.
Well, x can be any number, right, guys?
Yeah.
Pick a number.
5.
5. 5 divided by 5. 1. Okay, what if x is 100? 100 divided by 100.
It's because they're the same.
They're the same. As long as they're the same, it's 1. So what I'm trying to tell you is this over this is 1. But what if I go x squared over x?
No.
They're not the same number, but if you look at it, this is really x times x, right? Over what? X. Okay, what do you notice? This x divided by this x would do what? Cancel out. What's the answer?
X.
X to the first, right? Okay, what about this? X to the 10th divided by x to the 7th. Okay, Sydney, how'd you do that so quick?
10 minus 7.
Yeah, Sydney already knows this. When you have 10 x's on top, 7 on the bottom, 7 on the bottom will cancel with 7 on the top. What's left? 3. So she just says, just subtract that, minus that, and she's right. By the way, those are exponent rules. Exponent rules will come at you in February. We have a whole unit on exponent rules. But that's a really simple one, I think. Okay, now, how about this? 10 divided by 12. How do you reduce numbers? I get you know the answer. What is the answer?
5 or 6.
5 over 6. But here's what's happening, just so you know. 10 over 12 is really just 2 times 5, and 12 is really just 2 times what? 6. So when you write numbers as multipliers, anytime you have the same number over the same number, you can just cross it out and put a 1. So the answer is 1 times 5, 6, which is what? 5, 6. So really, that's what's really going on. Even though you don't ever do that, that's what's really going on. Okay, come on back. And let's look at this guy. Ready? Okay, 8x over 12x is really, if I do it the long way, guys, and I just do it the long way because these are your notes and I want you to see this. 8 is really 2 times 4, and then times x. And then this one is 12x, which is really, okay, you could do 2 times 6, but I'm going to try to use the 4. 3 times 4 times what? X. And now you have to look at it and say, well, what's the same?
4.
Not just 4.
Oh.
A 4x is the same as a 4x, which means the answer is what?
2/3.
2/3. Okay. Now, I get it. You can do that really fast. You probably don't need to show that work. I just did because I want you to see it. You are allowed to take a monomial and divide by a monomial. You are also allowed to take binomials and divide by what? Binomials. Okay, that's an x plus 2 times an x minus 5 divided by an x plus 2. What do you think you can do?
Get rid of it.
X plus 2.
X plus 2 with an x plus 2? Are they the same?
Yeah.
You positive?
Yeah.
Okay. Tell me why an x plus 2 and an x plus 2 are the same. Tell me why.
Same numbers.
But how do you know?
This is a variable plus 2. Oh,
Can you give me a number for x?
yeah. Oh, but we don't know because x can be.
What?
5.
5? Okay, you're saying 5. So 5 goes here, 5 goes there. So what does this really say to you now?
5.
7 divided by 7. Are they the same?
Yeah.
Yes. So guys, I'm trying to tell you an x plus 2 and an x plus 2 are exactly the same. And because they are the same, go ahead, cross them out, cross them out. And if they're the same, this goes into this 1 time. So when you cross things out, you're supposed to say 1 over 1. Okay? All right, go back. And this will cross out with this. And the answer is what? X minus 5 is the answer because it's the only thing left. Okay? All right. Now, pay attention to this one. This says a monomial divided by a binomial, and this is not true. Guys, what's on top is what? That's a binomial being divided by a what? A monomial. Okay. What do you want me to do?
Take out the 6.
Cross out the 6's? What's the answer?
X.
X. Everybody agree?
Y plus 1.
Everybody agree?
Yeah.
Okay. You're all wrong.
X plus 1.
You're all wrong. Let's take a look. Let's take a look. Ready? X plus 6 divided by 6. Is that what it said? Yeah. Okay. Oliver, give me a number for X. Oliver says 3. Okay. What you guys are telling me is I'm supposed to cross this out, and the answer is just this number, right?
No.
Well, no, but that's what you said. Cross it out, and the answer is just X. Okay. Well, here's the deal. If you put a 3 in, it says what? 9 over 6, doesn't it? Or this is a 3. Okay. 9 over 6 actually reduces to what? 3 over 2. So if I put a 3 in, I get 3/2. But you guys are telling me I can do this. You guys are saying cross them out. The answer is just 3. No, it isn't. The answer is what? 3 over 2. It can't do it. Now here's why. Come back. That's a binomial. That's a what? What? 2 terms versus 1. You can never, ever, ever touch a binomial with a monomial. That's like taboo. You can't do it. If you ever do it, you will get this wrong. Guess what? You can't touch them. So what's the answer? What? What's the answer? Yeah, it's basically you're staring at the answer, guys. An x plus 6 divided by a 6 is done. You can't touch them. And the only reason you can't touch them, one's a binomial, one's a monomial, and I told you, don't ever touch them. All right, you'll get burned, okay? All right, here we go. All right, first one is a monomial over a monomial. Can I reduce? Yes, you can. All right, let's do it. All right, I'm going to kind of do it the longer way, just to show you the work behind it. But basically, 6x cubed is, I'd probably go at 2 times a 3, and then x. All right? I get it. You can do this faster. And a 14 is just a 2 times what? 7, and then times x. Now, what do you see that I can kind of get rid of?
2 and 2
And then 2 of the x's like this?
Yeah.
Okay? And every time you do say, I got rid of them, you actually have a 1 here, and these make 1. So now the answer is what? 3x times 1 and 1 is 3x over 7. And that's about as easy as it gets. Monomials are typically really easy. All right, there's your binomials. I take that back. Binomial. Monomial. There's only one monomial here. What can't we do? You cannot touch a monomial with any of those binomials. That x will never go away. It's always going to be there. Okay, what binomials canceled out? X plus 1. There's an x plus 1. You can put a 1 there if you want. And now the top is what?
It's x over x plus 1.
Okay, that's what you guys say the answer is, right? Is that the answer?
No.
Yes, no? Which one?
Because you can't touch the one.
Because you can't touch a monomial with a binomial. You know how many students want to do this? Watch this. I cannot tell you this happens 10% of the time. I have 70 students. 7 of the 70 will do this. Hey, that's an x. Woo! The answer is 1/3. And then they circle it and they move on. It's wrong. You cannot touch monomials with binomials. So guess what? Don't do what I just did, please. Okay, the answer is what?
X over
X over
x plus 3.
x plus 3. You got it. We're done. That's reduced. Keep going. Okay, look, I got a monomial on top. I got a binomial on the bottom. So is that it? That's the answer. Guess what? It could be the answer, but you got to look close because this word comes in. If you can factor, you should factor because there's a chance you can factor it and then cancel. So the 4 is unfactorable, so we leave it. Okay, here comes your factoring skills. Ready? Help me out.
X plus 1 x
It's not a trinomial.
Taking X out.
Yes, you can never forget GCF. GCF is first. Okay, tell me what comes out. A what?
X.
X comes out.
X plus 2.
And then what?
X plus 2.
X plus 2. Okay. Do you see the 4 as a monomial? What's this?
Binomial.
Okay, don't touch them. Can't touch them. Do you see the 4 and the X? They're both monomials. What does a 4 and an X reduce to? Can they cancel out?
No.
Guess what?
It's done.
We're done. We factored it, but it just didn't help us. So we circle it and we just say that's the answer. You have to factor because if you factor, there's a chance something will cancel. Did anything cancel? No. Okay, so we wasted our time, but that's okay. We just move on now. All right. Help. Binomial divided by a binomial. Are they identical?
No.
No. So we got to factor them. Can you factor the top?
Yeah.
Yeah.
X.
You can. How do you factor the top?
Oh, no.
You can't take out an x, you can't take out a 4. Is it the difference of 2 perfect squares? No. Okay. That's done. Bottom?
Yes.
Yes?
No.
No?
You can do
Who are we looking at up here, guys? Sophia? You can't remember the name of your best friend? You're looking at your best friend. I told you, this is your best friend. The difference of what? 2 perfect squares. You guys, this is your best friend. It's factorable in 10 seconds or less, maybe 5 seconds. Okay. Sophia, tell me it again.
X plus 4, X minus 4.
Okay, so Sophia says x plus 4, x minus 4. The problem is 16 is first. So you kind of have it backwards, Sophia. It should be what?
4 plus X
4 plus x, 4 minus x. So that's the way it should go, because the 16 was first and the x squared was last. Okay. All right. Now we got binomials everywhere. Are any of them the same?
Yeah.
Yeah.
Which ones?
Top and middle.
Well, it's got to be this one with something. Which one's the same?
4 minus x.
This guy?
Yeah.
Same?
Oh, no.
Same? No?
Yeah.
All right, let's take a look. X minus 4. Is an x minus 4 and a 4 minus x, are they the what? Are they the same? Can I just cross them out?
No.
Okay, give me a number for x. Just give me any number.
9.
What? 9. Okay, 9 goes in here. 9 goes in here. You would get 5 over,
-5.
which makes
Negative.
not 1,
Negative.
-1. They're not the same. The word was what? They're what? Yeah, they're different, but there's a word for this. A positive 5 over a negative 5, those are called what kind of numbers? Different, yes. There you go. You guys, you're staring at opposite numbers. If you're staring at opposite numbers, the answer is what? -1. Yes, you can cross them out, but you can't put this. Watch. You can't go like this and this and put a 1 here. You got to put a what?
-1.
It's a -1 because they're opposites. And you have to recognize what opposites look like. So tell me the opposite to this one. Ready? What's the opposite to that? 2x minus 5.
5 minus
What?
5
5 minus 2x, he says. You know what? You know how you do this? You just go, hey, look, the 5 is negative. Here, the 5 is positive. Hey, the 2x is positive. Hey, the 2x is negative. As long as everything's opposite, you're staring at what? Opposites. Okay. Go back here. And go down here. And then let's just do this one. Okay. Yes, I can cross them out. But I cannot put a 1 over a 1. I got to put a what? A -1. So what's the answer, guys?
-1.
-1 over what? 4 plus x, yeah. Or could I have done this? -1 over x plus 4. Is this
Yeah.
and this the same?
Yeah.
How do you know?
Because it
Addition doesn't matter. Like, hey, what's 2 plus 3?
5.
What's 3 plus 2? See, it doesn't matter. Okay. All right. All right. Now, look. Trinomial over a trinomial. Are they identical? If they're identical, cross them out and put a 1. Are they identical? No, they're not even somewhat. X squared is the same. 2x and 1x, not the same. 3 and 6, not the same. Guys, what do we got to do? We got to do what? Factor. All right, go. This is where your factoring skills come in right now. Trinomials typically factor into what? Binomials, right? There you go. You got to find two numbers that give you -3 when you multiply, but add up to -2. Addison, do you have the top then? Okay, x plus 1, x minus 3. Is it -3 times a 1? -3, yes. It's -3 plus 1, -2, yes. She got it. Okay, Logan, heads down. You must have it done. What's the bottom? X minus 3, x plus 2, he says. Check it out. Is -3 times 2 -6? Yes. Is -3 plus 2 -1? Yes. It's all factored correctly. Are there any binomials that cancel? X minus 3 with an x minus 3. When you cancel them out, just put a 1. So now the answer is what?
X plus 1 over x.
Yeah. And why can't I cancel out the, let's say the x's? Why can't I just knock out those x's and call it 1/2? Because they're binomials. They're hooked together and they have to be identical. Are they identical binomials? No. You can't just pick a piece of the binomial and cancel out. You can't do that. That's the answer. You're done. Last one. Go. Like I said, your factoring skills are now huge. I'm going to just tell you, there's a GCF in both. Please do it. Rylan, did you get the top GCF out of that? Matt?
Oh, yeah, I'm still working on it.
I'm just talking the top. Is Ethan?
Yeah.
What'd you get?
Yeah.
Yeah, but 2 times what?
So,
Okay.
I have
Who said I have? Okay, go ahead, Dylan.
x squared minus
Okay, yep. Okay, so Delvin got us going on the top. Do you see a number on the bottom that they share? Take out a 4, yep. Okay. Okay, get it? And now what would be left if I took out a 4? X squared minus 2x. Okay, now please don't stop. Don't stop. Look inside. That's a binomial. Is it factorable? That's a trinomial. Is it factorable? The answer is yes and yes. Keep going. Factor. Factor until you can no longer factor. Sure hope you know you're staring at your best friend on top. It's the difference of 2 perfect squared. It should be factorable in 2 seconds. What is it? X plus 6, x minus 6, done. That should be an easy one. The one on the bottom is going to take more thinking. Give me 2 numbers and multiply, give me negative 24, but we'll add up to negative 2. They are x minus 6, what? X plus 4. Okay, hang on. Is this times this negative 24? Yes. Is this plus this negative 2? Yes. We got it, guys. We're ready to go. The 2 and the 4 are called monomials. You can touch them. 2 fourths reduces to what? 1/2. Okay. So right now the answer is 1/2. Okay. What? X minus 6. With what? X minus 6. And they are the same, so when they're the same, I just put a 1 here. Okay. So now, how about x plus 6 and x plus 4?
No.
Not even close. Don't touch them. So the answer is 1 times x plus 6, 2 times what?
X plus 4.
X plus 4. Okay, and I'm going to allow you just to stop there. You don't have to distribute. You don't have to do this and this. And by the way, would that do anything?
No.
No, that's just silly. Why would we even put the 1 there? But if you like to see the 1, put the 1 there.
Wait, are there tests to get distributed?
No, I'm telling you not to do it. I'm just trying to say 1 didn't even matter. Now, if you wanted to, and you ran the 2 through, the answer would be what? X plus 6 over what? Plus 8. Please, just don't do it. Please, just stop there. I'm done. What's the assignment?
Oh.
Delta math. 10 problems. Go. Some people in period 1 said, do I really have to show all the work? Yeah, you do. Guess what? If you cannot look at these problems and just come up with answers. Take out scratch paper. Get going. Oh, yes, you did. Well, you have the pack. Remember the Tuesday, Wednesday? There was multiply Tuesday, division, and then
Okay,
What-
that part that takes
hey,
very long.
1 through 20, all the answers have been posted. Okay.
You have to write.
I promise you can't do these. You're gonna have to take out some scratch paper. I'm not gonna require you to give me scratch paper. You just have to get me the right
You have
answer.
to do
So we don't have to bring this back?
No, you don't have to, but I guarantee you'll have to do it.
But then,
Before you leave, will you just, if you are done with the complex numbers Tuesday, Wednesday, Thursday, drop it in the bin before you leave. Okay? If you're not done, you're not done. Try to get it done over the weekend. We will be quizzing on Friday next week. Not quizzing, testing. Okay, I got to see that you're in it. Are you ready? You're in?
just finished off.
There's a chart. Oh, so there was a chart. Hold it. You guys not charge your
Oh, I leave it in my truck.
Oh, that's a good place to leave.
So it's really cool.